in exercise W-2 we'll be solving two problems simultaneously. The first problem is to design the drum for the winch, and the second problem is to design a drivetrain for this winch. So what we know is how fast we uncoil a cable on and off the winch, and we know at what speed it is going to happen. We also get fixed the capacity of the winch. This is how much of the cable can be stored on this winch, and it is fixed in cubic meters. We will be playing with some parameters of the drum, its length and the two diameters, and we will see that shape of the drum affects the drivetrain. So our task is to optimize each time. So we take one shape of the drum, length and diameters, and we try to optimize the drivetrain for lowest cost. Then we note down what we got, all the parameters. So this is case number one, and then we should change the shape of the winch and change the length or diameters and see what we get on the drivetrain side again. So we do it again and again, and we investigate the space of the three winch drum parameters defining its shape, and we see which variant is the best. Overall goal is to have lowest possible drivetrain cost, and as you see, the cost of the drum itself, we just ignore it because it is going to be more or less the same for all shapes. So here is the expression describing the relationship between the diameters and the length of the winch and how much cable can be stored on that winch in cubic meters. We know that we have this volume fixed to 1 cubic meters, so V equals 1. So what we're going to do, we can just vary all the parameters and see what we get. So if we fix L to 1 meter, length 1 meter, and say D2 to say 1 meter again, we can calculate what D1 becomes. And we take these three parameters to DriveConstructor and design our drivetrain for these three parameters. And then we do it again. We choose L equals 0.5 meters, and D2 we leave 1, for example, and again we calculate D1 and take these three parameters to DriveConstructor. So we should try topologies with and without gearbox here. So first without gearbox. So anyway, we have entry fields for drum diameter when it is empty and drum diameter when it is full, and there is no entry field for length L at all, but it is not needed. And also we need to enter the force and the speed of the line and overloads. And then we play with the parameters of the components as usual to trying to minimize the cost of the system. Then we may choose a topology with the gearbox, and we do the same again, so we can play with the gear ratio to see how the cost of the gearbox changes and how cost of the motor changes, and come to optimal design. Again, this has been done for only one shape of the drum, so it should be repeated for a few other shapes of the drum to find the optimal shape. So of course we do not need a very accurate results. So the point here is to identify the trend. So is your optimal winch going to be long and with small diameter, or opposite, very short and with large diameter? So this you should try to identify in this exercise. So just try 5, 6, maybe different shapes and see where you go, what the trend is. That's basically it. Thank you for watching.